Okay, let's take a look at a few examples from section 1.6. We'll start with number 28. We're asked to find the inverse for the function f of x is equal to 2 minus e to the x. And so it should be a natural log involved, since we know that the inverse function of e to the x is the natural log of x. Let's go ahead and follow our steps. Remember, the first step was to replace our function notation with y. So I have y equals 2 minus e to the x. The second thing we want to do then is solve this for x. Solve this for x. And so if we do that, we'll have to get x by itself. Alright, fair enough. We'll subtract a 2 from both sides. So I have y minus 2 is negative e to the x. Now let's distribute a negative through both sides, so that'll change the signs on the left. We'll just make that a positive 2 and a negative y, and I have an e to the x. Well, I'm going to have to undo this e to the x. What do I do to undo that e to the x? Well, I'm going to apply the natural log function to both sides. I'm going to take the natural log of 2 minus y and the natural log of e to the x. So remember what that means. This is the exponent on e. Remember, this is a base e log. The exponent on e to get e to the x. These are inverse functions. They undo each other, and I'm just left with x on the right side, which is what I wanted since I'm trying to solve for x. So x is the natural log of 2 minus y. And so let's go ahead then, and step 3, remember, is to replace x with y and y with x. So I have y is the natural log of 2 minus x. And finally, our fourth step is to replace y with the function notation. Since our original function was called f, let's call the inverse f inverse. Let's go ahead and plot these two functions to verify that they are inverses graphically. Remember that functions are inverses graphically if they are reflected over that line y equals x. Well, you can see here, here's e to the x and natural log of x, by the way. You can see they are inverses graphically. All right, let's go ahead and first of all edit this one. This was 2 minus e to the x was our original function, so it looks like that. Now we should hopefully get a reflection over the line y equals x by changing the natural log of x to the natural log of 2 minus x, which is what we found the inverse to be. And sure enough, you can see that we do have inverse functions. They are mirror images of each other over that line y equals x. Okay, let's go ahead and look at another example. 8, we're given the natural log of x plus a times the natural log of y minus b times the natural log of z. Remember, we have properties of logarithms that are true for any base. In particular, they're true for the base e, or natural log. We want to express this as a single logarithm. And so we're going to use those properties that we talked about in the lecture B there, the properties that are found, or actually they're called laws, in the book on towards the top of page 68. 3 properties, 1, 2, and 3. The first property I'm going to use is the one that allows us to put exponents up in the, coefficients up in the exponent. So I'm going to say then that the natural log of x plus a times the natural log of y minus b times the natural log of z is equal to the natural log of x plus the natural log of y to the a power minus the natural log of z to the b power. That was property 3 in your textbook. Okay, now I'm going to use, let's go ahead and combine these two with subtraction by using property 2. This is going to be equal then to the natural log of x plus, remember, the natural log of something minus the natural log of something else. We can write that as a single log, y to the a over z to the b. Okay, that's true for the log of any base. Just make sure that the bases are the same. Finally, by property 1, two logs that are being added together can be written as a single log by taking the things we're taking the log of and multiplying. So we have x times y to the a over z to the b, or if you like, we could write that as the natural log of x times y to the a divided by z to the b. So that's just an application of those properties of logarithms. Let's look at another example where we are asked 55, we want to find the domain of the function and the inverse in its domain. Our function in 55, as you'll notice, is the square root of 3 minus e to the 2x. Let's talk about the domain of this first. We have a square root, and remember, if you're going to take the square root of something, you have to make sure that what you take the square root of is 0 or larger. So we need 3 minus e to the 2x to be at least 0. So let's solve this equation for x. This is an exponential, well, let's solve this inequality, I guess. If we add an e to the 2x to both sides. Alright, let's go ahead and get rid of that e, that exponential base e, by taking the natural log of both sides. We can think of it that way. Natural log of e to the 2x. So I have the natural log of 3 on the right, greater than or equal to the natural log of e. Those are inverse functions. I get back 2x. So dividing both sides by 2, I get then that x must be less than or equal to the natural log of 3 over 2. There's my domain. My domain is x is less than or equal to, let's write it that way, the natural log of 3 over 2. In interval notation, we would say then that it's everything from the natural log of 3 over 2 on up to infinity. Okay, so there's our answer to part A of this problem. Now part B, we are asked to find f inverse and its domain. So going from the fact that f of x is the square root of 3 minus e to the 2x, we want to first of all find f inverse of x. So we'll follow those steps that we talked about. The first step, remember, is to replace our function notation with a variable like y. Second thing is to then solve for x. So solve this equation that we have resulting for x. Well, I need to get x by itself. The first thing I can do is get rid of that square root. So I have y is the square root of 3 minus e to the 2x. Let's get rid of that by squaring both sides. So y squared is equal to 3e minus e to the 2x. Okay, trying to get x by itself, so let's isolate that term that has x in it, that e to the 2x term. So we'll subtract 3 from both sides. So I have y squared minus 3 is a negative e to the 2x. Let's go ahead and get that negative off of there. Multiplying both sides by a negative, that'll change the signs on the left. That'll be a positive 3 and a negative y squared. E to the 2x. Now to undo this e, to get to this x that's in the exponent, we can use a natural log. So we'll say then that the natural log of 3 minus y squared is equal to the natural log of e to the 2x. The natural log of 3 minus y squared then is equal to, these undo each other, their inverse functions is 2 times x. Dividing both sides by 2 gives us x, the natural log of 3 minus y squared. All of that divided by 2. Now, our fourth step then, actually our third step, is to switch x and y. So y is equal to the natural log of 3 minus y squared. All of that divided by 2. Our fourth step, let me come up here just to keep it on the same page. Our fourth step then is to replace y with the function notation. Since our original function was called f, our inverse is called f inverse, and it's the natural log of 3 minus y squared over 2. Okay, now we want to find the domain of this function. So remember that the domain of a logarithmic function in general is well, from 0 to infinity. Remember we talked about you can't put a negative number or 0 into a log function. That means that I'm going to need, actually this should be an x here. It's a function of x. I didn't switch it, did I? This should be an x right here. Let me go back up. Oh yeah, this should be an x here. Sorry about that. And this should be an x right here. There we go. Okay, so we're going to want to make sure we don't put anything that's negative or 0 into our natural log function. So that means we're going to need 3 minus x squared to be 0 or larger, which means we're going to need 3 to be bigger than or equal to x squared. Well, that means if we want x squared to be less than or equal to 3, that means we have to make sure that x itself is less than the square root of 3, but also has to be bigger than the negative square root of 3. For example, if x is negative 2 squared is positive 4, which is not less than or equal to 3. So we're going to need this interval from negative square root of 3 up to positive square root of 3 as the domain of our inverse. Remember, because we have to make sure that we don't take the log of 0 or a negative. Now, as I say that, I realize I made a mistake. We can't take the natural log of 0, or any log of 0 for that matter. And what I've done here is set up an inequality that implies that we can. So we need to be strictly bigger than 0, which means 3 is strictly bigger than x squared, which means x squared is strictly less than 3, which means x has to be strictly between negative square root of 3 and positive square root of 3, which means we need parentheses on here, and plus it's a crappy 3. So let's go ahead and just rewrite that. Whoop. Oops, with a pen would help. There we go. So between negative square root of 3 and positive square root of 3. The word for 1.6 is going to be the word penultimate. Penultimate, P-E-N-U-L-T-I-M-A-T-E, which means simply next to last. As you'll notice, 1.6 is the penultimate section in Chapter 1. So good luck on your homework.